Okay, in this presentation we're going to use the Moivre's theorem to find the roots of this expression here. Minus 2 times root 3I. Okay, and this expression here is z to the power of 4. Now what I'm going to do here is actually express it out using in polar form using these two calculations here. Basically, I'm just giving you a head start in this. So z to the power of 4 can be written as 4 times cos of 4 pi over 3 plus I sine 4 pi over 3. Okay, and essentially what we are asked to do is find four solutions for z, or find the four roots of this expression here. So I'm zigzagging up and down. So the general form of z to the power of 4 is as follows. Essentially, it's just like what we have here, okay? But essentially, we just add in this term here, 2n pi, okay? Just in here, we just replace it with this here, okay? So essentially, we switch it to 4 pi over 3 plus 2n pi. Okay, so when that is z to the power of 4. So when we actually just use the Moivre's theorem, we would just express z or z as 4 to the power of 1 quarter. That actually works out to be the square root of 2. 4 over 3, 4 pi over 3 divided by 4. Okay, here n is equal to 1 quarter. Okay, just if you're not familiar with the Moivre's theorem, you should go back over that first off. But essentially, what we're doing here basically is we're dividing this expression here, which is exactly the same as this expression here. We're just going to divide it by 4. So we end up with 4 over 3 plus n over 2 times pi. Pi over 3 plus n over 2 times pi. Pi over 3 plus n over 2 times pi, which is essentially this expression here divided by 4, or 1 quarter of it. So essentially what we've got to do is just evaluate it for 0, n equals 0, 1, 2, and 3. Okay? That's the four roots, starting with 0. Okay? To get the four different solutions. So essentially what we're going to do here is where we had 2n pi, we just put in a value for n here. N equals 0, 1, 2, and 3. Okay? And we just re-evaluate the whole thing. Okay? Sorry, actually, this has now become n pi over 2, actually, for z. So that's just to be a bit clearer about where we're going with that, n2 over pi. Okay? So, in this particular instance, n over 2 is 0 over 2, which is 0. So, we just disregard that part there. Okay? So, essentially what we have to do is calculate cos of pi over 3 plus I sine pi over 3, and we end up at 1/2 plus I times root 3 over 2. Okay, and remember we have r out here, in this case, or r to the power of 1 quarter, and that is square root of 2. So we just multiply the whole thing out, and we end up with 2 pi over 2 plus square root of 2 over 2 plus square root of 6 over 2 times I. Okay, so we do that exact same calculation now for n equals 1, 2, and 3. So I'll just sort of speed it up here. So n pi over 2 just simply gives us pi over 2. So essentially what we do here is we add pi over 3 and pi over 2. Okay, we end up with 5 pi over 6. And again, we have square root of 2 out here, which we're going to just come back to the end. So the cos of 5 pi over 6, that works out to be minus square root of 3 over 2. Sine of 5 pi over 6, that's 1/2, bit of calculator work. And when we multiply this by the square root of 2, we get minus 6 over 2, minus the square root of 6 over 2, plus I times the square root of 2 over 2. Okay? So I'll just be very quickly here. N over 2 times pi, here n is equal to 2, so we end up with 2 over 2 pi, which is just pi. Okay, so working that out, we would get 4 pi over 3. Okay, and when we evaluate cos and sine of 4 pi over 3, we get minus 1/2 and square root of 3 over 2. So we have minus 1/2 minus I square root of 3 over 2. And again, we have r this value for r, or actually I really should say r to the power of 1/4. Essentially, we have that value out there, and we just multiply it through, and we will get minus the square root of 2 over 2 minus I times the square root of 6 over 2. Okay, so that's the third root. And one more. Here, n is equal to 3, so we end up with this expression here, pi over 3 plus 3 pi over 2. That turns out to be 11 pi over 6. Cosine sign of that, minus the square root of 3 over 2, and minus 1/2. And so we end up with minus the square root of 6 over 2 minus I times the square root of 2 over 2. So it actually is quite a repetitive process, okay? You just actually have to do it out each time, okay? It just sort of work through it. So it's actually quite an easy thing to do. It's just a lot of repetition there. So, and again, de Moivre's theorem is vital in this. Okay, you will have to know that. Okay, we'll leave it there.